Hello, I am Olalekan Badmos and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents, alright, who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. Alright, so we'll continue our lesson on circle geometry. And today we are learning to prove the theorems of a cyclic quadrilateral and also to solve applied problems on circle geometry. So far we've been able to prove 3 circle theorems, and today we are going to look at 2 more, and that will be on cyclic quadrilateral. So first, what is a quadrilateral? A quadrilateral simply refers to a figure or a shape with 4 sides, right? Any figure, any polygon, right? Any polygon that has 4 sides is called a quadrilateral. Examples: square is a quadrilateral, rectangle, rhombus, parallelogram, right? Those are examples of quadrilateral. So any polygon that has 4 sides, that is bounded by 4 sides, right, is called a quadrilateral. So then, what is a cyclic quadrilateral? So a cyclic quadrilateral is the quadrilateral whose vertices touch the circumference, right? The circumference of a circle. So the first thing we do is to draw a circle. So we have a circle, right? And with a center. Now, don't forget I mentioned that a cyclic quadrilateral simply is a quadrilateral that the vertices of that quadrilateral are found touching the circumference of the circle. So here we have a circle, and then let's see, we have, this is our radii, this is the center of the circle O. Alright, so let's draw a cyclic quadrilateral. Now don't forget, again, a quadrilateral is a shape that is bounded by 4 sides. So here, this is the first vertex A, the second is B, the third is C. Then let's have the fourth vertex here, D. So ABCD is a quadrilateral. Okay, let me name it properly. All right, ABCD. ABCD is a quadrilateral. ABCD is a quadrilateral, not just a quadrilateral. It is a cyclic quadrilateral because the vertices, right? This is a vertex. This is a vertex. This is a vertex. This is a vertex, right? One vertex, but 4 vertices. So the vertices, right, touch the circumference of the circle, right? Also, another way to put that is that the quadrilateral is inscribed in a circle. The quadrilateral is inscribed in a circle. So, how do we prove, or what are the theorems to prove here? Alright, so we are going to first prove the first theorem of this cyclic quadrilateral is that the opposite angles of a cyclic quadrilateral, right? The sum of the opposite angles of a cyclic quadrilateral is 180 degrees. So how do we prove that? Now, don't forget I said that the first circle theorem that we proved is pivotal to other theorems. Very pivotal to other theorems. So here, this is the center of the circle, so there's an angle that is subtended by the 2 radii, right, OB and OD at the center of the circle, right? So we observe properly, there's also an angle at A, right? There's an angle at A. So we know from the first circle theorem that the angle at the center of the circle, right, is 2 times the angle at the circumference, at the remaining part of the circumference, or at the circumference, right? So how do we go about this? Now, take note of this. We've been able to establish before right, that the sum of angles at a point, right, is equal to 360 degrees. So observe this. There's also an angle here, right? So let's write out the two of them. So we have the angle, right, at the center, and then there is the angle at the circumference. So let's see. Let the angle subtended by the two radii OB and OD be x, and let the angle the other angle around it be y. So you observe closely that there are two angles at a point here, right? So we can say that x plus y is equal to 360 degrees. The reason is the sum of angles at a point, right, is 360 degrees. Sum of angles at a point, 360 degrees. Now, we know, right, before now, if x and y, x plus y is 360 degrees. Now, going by the first theorem, the first second theorem, that the angle at the center, right, is 2 times the angle at the circumference. The angle at the center is 2 times the angle at the circumference, right? So if we look properly, now if these two angles, right, now give 360 degrees, pay attention closely, Now angle x, right, is 2 times the angle at A. So let's put this properly. The angle at angle x is equal to twice the angle at A, at BAD. And what's the reason? Angle at the center, right, is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. Right, so x is equal to 2 BAD, right? That's twice the angle at the circumference. So you will also take note that, right, that y also is an angle at the center. Y is also an angle at the center, right? And then this angle at the center is also twice the angle here at this point at C. Is twice the angle at C. The same reason. So write y is equal to twice angle BCD. Right? We have the same reason. Angle at the center. Angle at the center is twice angle at the circumference. Angle at the circumference. Alright. So x is equal to 2 angle BAD, twice angle BAD, right? X, the angle at the center subtended by the two radii, is twice the angle at BAD, right? Y, alright, is also angle at the center, that is twice the angle at this point, right? At the circumference here, that's twice the angle BCD. So take note that if x plus y is equal to 360 degrees, pay attention, if x plus y is equal to 360 degrees, right, and then we know from what we have proved that the angle at the circumference, the angle at the center is twice. So if this is 360 degrees, if the sum of these two angles, right, give 360 degrees, right, what that means is that the sum of the two angles at the circumference will also give half of the two angles at the center here. Do you understand that? I'll take that again. Now, if x plus y equals 360 degrees, and that's because the sum of angles at the point, right, is equal to 360 degrees. If the angle, the two angles at the center, the sum of the two angles at the center, right, gives 360 degrees. And we know from the first second theorem, right, that the angle at the center is twice the angle at the circumference. So if the angles at the center, in this case two angles now, we were looking at just one angle before. Now we have two angles at the center. if the two angles at the center equals 360 degrees, and the theorem, the first theorem states that the angles at the center is twice the angle at the circumference. In this case now, the two angles at the circumference. So if the angles at the center is 360 degrees, right, it suffices to say that the angle at the circumference will be half of the angle at the center, because angle at the center is 2 times the angle at the circumference. So if the angle at the center is 360 degrees, it means that the angle at the circumference, the two angles, right, these opposite angles will be what? Will be 180 degrees, which is half of 360 degrees. So if you take note of this, you will see that the angle at A and the angle at C, they are opposite. They are opposite angles of the quadrilateral, of the cyclic quadrilateral, right? They are opposite angles of the cyclic quadrilateral. So that means that, so we now have the theorem of the cyclic quadrilateral, that opposite angles of a cyclic quadrilateral, the sum of opposite angles of a cyclic quadrilateral is equal to 180 degrees. So let me put it into writing. So if x plus y is equal to 360 degrees, sum of angles at a point, right? And here we have x to be 2, the angle, twice the angle BAD, and we have y to be twice the angle at BCD, the angle BCD, right? So that means that this also will be equal to 360 degrees. All right, so let us factorize 2 here. So we have the angle BAD, right, plus the angle BCD, right, to be equal to 360 degrees. So divide both sides by 2. 2, we cancel out 2 here. So therefore, right, we have the angle BAD plus the angle BCD. 2 here, 1, 2 in 360 is 180 degrees. So the theorem states that the opposite angles, the sum of opposite angles of a cyclic quadrilateral is 180 degrees. I hope this is clear. Alright, so I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like and share to everyone around you so you can get more notifications. Thank you. Bye.